Hi, and welcome to the final project requirements video. In this video, I'll talk about the requirements for the final project and talk about some different things, as well as what the expectations are for hardware. So first, I'm in the final project section of the lab, and we'll go over talking about is this document. So this document is the requirements of what we're expecting for you guys to do for your final project. So there's a couple different key areas. First is the hardware. So in the hardware, um, you're only allowed to be used the STM32 or the PIC24 Curiosity Development Board to interface with sensors, electromechanical devices, digital, analog I/O. So pretty much the base of the project should be based around one of those two microcontrollers. Now, you can use a Raspberry Pi. It is not required. It is purely optional, but its only use should be Internet of Things or data logging. It cannot be the main component of your project. And finally, we do not allow Arduino-based products to be used in the class. That includes the final project. I understand the STM32, there's ways of loading Arduino-based software on there. That will not be accepted. So please keep that in mind as you're going through your project on how to go about doing it. So the goal of the project is really to design or use microcontrollers in an interesting manner, right? So we're trying to apply these devices in some interesting way, right? If it's automating a process, if or existing process, or if it's finding a new or creative way to interface with them, right? So it doesn't have to be the current scale. So if you're interested in like power design or something much larger, you don't have to build to that scale, especially because of cost and concerns with power, with safety. So it can be much more of a reduced scale or like a proof of concept. So just keep that in mind as we're going through it. Now, for the software requirements for the project, you will be required to have a finite state machine. It must be incorporated in the project and it must be clearly documented and code must be provided. And this will actually be reviewed by me as part of one of the demo requirements. Now, because obviously we're in a remote format and it is much harder for you guys to meet in person, depending on where you're living or where you're at, it's fine if the project is not fully complete. And I mean by that sense of if everything's not fully integrated together, that's perfectly okay. The way I see it is each of you are working on parts of this project and we'll review how far we're at those parts. But one of the ways for us to do this is we want to look at making test cases, having a clear defined way of what you're going to test and seeing what the result is. And this gives us a good idea of where we're at with the development of this project. So each person is going to be responsible for drawing up some test cases for the code or for the hardware. And then each person is going to be responsible for either doing some of these test cases. And the goal of this is at first, we want to test minor things within the project and then finally test the overall thing if we can complete it putting it together. If you don't complete the overall project, it won't hurt your grade. But I do want to see test cases performed as it shows me the work that you have completed. If you've only provided um, code, but it's never been run or tested on the hardware or tested against some type of control cases, then we don't know if it's complete. So by running these test cases, even if it's in a very controlled environment or for the very direct number that we provide, at least we've confirmed what some things have been working in the project. And then finally, the final requirement for the final project is proper planning and documentation. So a lot of the stuff where you guys are turning in the final project description and your final project report, your presentation, all of these are part of that process. So making sure we submit that and all of the stuff is clear defined is an important part of it. So you may need to make sure you perform proper planning must be demonstrated. That's part of the final project description. Proper documentation, that's referring to the lab report. And then graphs, figures, tables that you need to collect need to be in that documentation themselves. So overall, the project should be very, take it step by step as we go through it. If you run into roadblocks, or you hit errors, that's perfectly okay. I'm not expecting you to have everything working perfect by the end of this semester. I'm only expecting for you to get to each step and let's get as far as we can. So it's getting you exposed to this process of how do you do a project, how do you work within a team, and it's really kind of getting there a little bit by little bit, and also learning a little more about microcontrollers as we do it. So with that, I know the question comes up a lot of, Sean, do I need to buy hardware? And the answer to your question is no, you don't actually need to buy hardware. So I'm going to go ahead and first go to is there's a couple different sites we can use. One is a company called Adafruit. They sell a lot of sensors now, or different devices. Now, we don't need to purchase anything from them, and also a lot of times they're not always the cheapest selection. But when we select parts or hardware, the great thing that they actually do provide for us is they actually give us some documentation. So let me go ahead. I'm going to actually find some sensors here. And I'm going to use this example is a temperature sensor. So you can see here I have temperature. And there's a multitude of different type of temperature sensors. So this is going to lead to the first thing for the project. For the scope of this class, we haven't covered some more complex, what's called communication protocols like I2C or SPI. We can take the time to work on those, but the problem is they're very difficult to solve without proper equipment. So if you get it and it works perfectly great, the problem is if you run into issues, it's very hard to figure out what those issues are without having some type of analyzers to look at it. The Analog Discovery 2 works great. It can actually have most of the analyzers we need to solve these problems, but unfortunately, we don't always have access to those. So for the purposes of the lab, I want us to try to focus on analog sensors, right? So if we look at the analog sensors, there's a multitude of ones, and there's actually some inside of your kits. And all of these they have, you treat them almost like a potentiometer. The voltage changes based off of the temperature data changing. If it's a different type of analog sensor, the same thing. So all we're doing at this point is we're just measuring voltage, which we can use with an A to C. So for here, I have an example as the TMP36. It's a very common and cheap. You can probably find them cheaper than this. But if I want to select this, now I'm not telling you to purchase this sensor, but for the purposes of the final project, what we can do is we can actually model around this sensor. So the great thing about it is they provide, or Adafruit or some of these other companies out there provide information like this. They provide basically is whatever voltage we're reading in, we multiply by 100 and subtract 50, and it now gives us the degree in Celsius. So we can actually model our temperature around this. So if you don't want to purchase a sensor or you don't have one, we can simply say, okay, let's go ahead and look at this equation and let me provide some voltage ranges to act as our temperature, right? So that way we can kind of, it's a lot more controlled. It's not using the sensor, but it's a way if we put the sensor in, ideally everything should be working, right? So, and we can do this for a lot of different sensors, not just temperature, right? But if I go back and let's go ahead and select, um, mm, see, microphone, sound, light, proximity. Let's see what they have here. Sometimes these ones aren't always, let's not do this. Barometric pressure, cover diode, proximity, a little easier. So some of these sensors, they're using digital I/O, but you can kind of look at them and see and read the data sheet. So again, the advantage of using a lot of these ones, like say the PIR sensor, is they provide lots of documentation. So here they provide documentation. It's a lot of it's with Circuit Python or Arduino examples, but it's enough to give us an idea that it's just, data coming into a pin. As we saw earlier, if you wish to do something like that, it's usually like, oh, if this signal comes high, right, then we detected motion. So a lot of these interfaces, besides analog, can be simple digital I/O pins. And you don't have to use Adafruit. There's other companies that provide this documentation, sensors. And again, don't need to purchase any of these sensors. I only want you to look at these as ways of modeling for your project, right? So you don't have to worry about ordering it. Is it going to come in time? Just first look at it and say, okay, you know what? I think I'm really interested in a microphone for my project for whatever reason. Well, let's go ahead and look at it. So one, you see this I2S. This is a digital protocol, so probably isn't good for what we want. But here I can see there's an out, a ground, and a VCC. So most likely that out is probably simply an analog signal that we're reading, right? Now, depending on the board, there might be some digital signal processing things that we need to be aware of, but maybe I can use something like this to figure some information out. And with that, I can model that data around what I want to do. So that's the goal for the final project. If you do have any questions, I know everybody is working on different things. There's plenty of questions. Feel free to contact me at any time, email, Canvas, Moodle, and I'll be happy to answer any question you have regarding the final project. Just keep in mind, the biggest thing I want to emphasize is the requirements, such as the hardware and software, as well as laying out the test cases. So please look forward. The next video I'm going to make is going over an example project, how I'd go about designing it, different test cases, how I design the finite state machine, and to go from there. So I hope this helps, and feel free to ask any questions again, and have a good day.